Hello, good people. How are you? I hope you are well. I'm Chirimashi Jairus, and I'm gonna take you through the entire syllabus of O-level mathematics. I'm introducing these lessons for your own good so that you benefit. You can start on your own, and you can start at home. Again, for you to benefit from this lesson and from the lessons which will come in the near future, you have to get a copy of TLC, Tirivashi Learning Center Mathematics Study Pack, so that we will move together. So today I'm gonna talk about the first topic, which is about numbers. I always tell my students that it is good for us to be good mathematicians, and it is good for us to pass the exam. So for us to know how to use numbers and when to use numbers, we have to know the definitions of numbers. This is my introductory topic, so that we will move together, so that when we are talking of integers, when we are talking of rational numbers, irrational numbers, sets, when we are talking of reciprocal, etc. in the near future, we will understand each other. So it is essential to know the definitions of numbers so that you will be able to attempt questions, e.g. when we are dealing with sets, and also in the topic which is probability. Okay, so today I'm going to talk about the definitions of numbers, the common definitions of numbers which are used in our syllabus or level mathematics. Right, number one, let me talk about natural numbers. Right. These are everyday counting numbers, or these are numbers which are used in everyday counting. Let's talk of 1, 2, 3, 40, 41, 42, etc. Another definition, some of the textbooks will say it is a set of positive numbers, and also they include 0. So some textbook they say it is a set of positive numbers, but before we move to positive numbers, we have to start at 0. So this is the definition of natural numbers. So if you are asked that set of A contains natural numbers between 1 and 15, then the next question they say, list the integers which are in set A. So you should know that natural numbers, examples 1, 2, 3, etc. These are numbers which are used in everyday counting. Okay, number 2, let us talk of integers. Number 2, let us talk of integers. Okay, these are positive and negative whole numbers. So we write here positive and negative. Please take note of this word, whole numbers. Whole numbers. And also don't forget that 0 is non-positive and 0 is non-negative. However, 0 is also an integer. and B, take note of this, 0 is also an integer. An integer. Okay, so examples of integers. Think of any positive number and think of any negative number. Okay, examples are, we can write 5 minus 6 minus 36. We can talk of minus 156. We can talk of 15, as long as it is the positive number and negative, I mean whole numbers. We are talking of whole numbers. And don't forget that 0 is also an integer. I hope we are moving together. So number 3, let's now talk about rational numbers. Rational numbers. Number 3, rational numbers. Right. What can I say? In my own terms, rational numbers, these are numbers which can be expressed as a fraction in this form, a over b, where a and b are integers. However, b is not equal to 0. A and b are integers. However, note that and b is not equal to 0, because if you say any number divided by 0, we'll get an error. It is not possible. So rational numbers, these are numbers which can be expressed as a fraction. So think of terminating decimals. For example, 0,5. This is a terminating decimal. 0,5 can be expressed as a fraction by saying 5 over 10, and it can be reduced to 1 over 2. So 0,5 is a rational number. Again, you can talk of think of recurring decimals as well, because they are also part of rational numbers. So I was giving an example of 0,3333, which is 1 over 3. Okay, as a recurring decimal can be written as 0,3. Then we put this sign here. Okay, so all recurring decimals can be expressed as a what? As a fraction. So when you think of rational numbers, think of terminating decimals, think of recurring decimals, think of proper fractions. If I'm saying proper fraction, for example, 1 over 3 is a proper fraction. The numerator is smaller than the denominator, so it's a proper fraction. When we talk of improper fraction, they are also rational numbers, because they can be expressed in the form a over b. An improper fraction is whereby the numerator will be bigger than the denominator. And also mixed numbers, for example, 1 and 3 over 4 is an example of rational number, because it can be expressed in the form of a over b by changing this to an improper fraction, whereby we say 4 times 1, we get 4, we add 3 and we get 7. This can be written as 7 over 4. So 1 whole and 3 over 4 is also a rational number. So in summary, in terms of rational numbers, think of all integers. Think of all fractions, and think of terminating decimals, and also recurring decimals. These are all rational numbers because they can be expressed in the form of A over B. They can be expressed as a fraction. Okay, let us move on to the next one. Right, number 4, irrational numbers. Irrational numbers. Right, this is the opposite of rational numbers. These are numbers which cannot be expressed in the form of A over B. These are numbers which cannot be expressed as a fraction. Numbers which can not be expressed in the form A over B. These are irrational numbers. For example, let's say square root of 2. Square root of 2 cannot be expressed as a fraction. If you use your calculator to find the value of square root of 2 and try to change it to a fraction using a scientific calculator, it won't be possible for you to do that. So square root of 2 is an irrational number. Again, square root of 3, square root of 5, and again pi, this sign. If you use your calculator and locate this button pi and you press it and say equal to, you'll find that the answer cannot be expressed as a fraction. Right, usually examiners require us to use the value of pi to take, for example, 22 over 7 as the value of pi. However, 22 over 7 is not the exact value of a pi. It is the approximate value of a pi. 22 over 7 on its own is a rational number. And pi relating to this sign, because the solution of this, the answer will not be able, if we get the answer from this side, we will not be able to express it as a fraction. Therefore, this sign pi is an irrational number. So, please note that 22 over 7 is not the exact value of pi. It is the approximate value of pi. Usually examiners give us that value so that it will be easy for us to use or to calculate, be it the perimeter of a circle or the area etc, or sector, segment etc. Okay, now we can move on to the next segment. So I was saying irrational numbers, these are numbers which cannot be expressed as a fraction. So think of square root of 2, square root of 3, square root of 5. Think of log 6. Log 6 can, the solution here cannot be expressed as a fraction. Again, log 6 is a what? Is an irrational number. Think of cos 13. Cos 13 degrees cannot be expressed as a fraction. So it's an irrational what? It's an irrational number. Okay, I hope we're together. We're still together. Now, let's move to number 5. Number 5, let us talk of prime numbers. Prime. Right, these are numbers greater or equal to 2 with only two factors, 1 and itself. For example, 2 has only two factors, 1 and 2. Another example, 3 has only two factors, 1 and 3. So 3 is a prime number. Another example, 5, 7, 11, etc. So all the numbers greater or equal to 2, which have two factors, they are called prime numbers. Okay, let's move on to number 6. Number 6. Even numbers. These are numbers which are exactly divisible by 2. Exactly divisible by 2. E.g. 2, 4, 6, 8, 10, 12. These are all examples of even numbers. We can see that if we say 2 divided by 2, we get 1. We don't get a remainder. So all the numbers which are exactly divisible by 2 are called even numbers. Number 7. Number 7. Let's now talk of odd, or double D, odd numbers. Odd numbers. So odd numbers are numbers which when divided by 2 leaves a remainder of 1. For example, we can talk of 3, we can talk of 7, we can talk of 9, we can talk of 21, we can talk of 37, etc. All these numbers, if we divide 3 by 2, it gives us a remainder of 1. If we divide 7 by 2, we get 3, remainder 1. So all the numbers which when divided by 2 leaves a remainder of 1, they are called what? Odd numbers. I hope we are still together. Okay, thank you. Now let us move on to number 8. Number 8. Perfect squares. Some mathematicians call them square numbers. This is another word for perfect square. Square numbers. So, perfect squares are numbers which can be expressed as a product of two equal numbers. These are numbers which can be expressed as a product of two equal numbers. For example, 1 is a perfect square because 1 can be expressed as 1 times 1. The next one, 4, is a perfect square because 4 can be expressed as 2 times 2. 4 can be expressed as a product of two equal numbers, which are 2 times 2. Again, 9 is a perfect square. 9 can be expressed as 3 times 3. 16, 25, 36, etc. These are examples of perfect squares. Okay. Number 9. We can talk of a perfect cube or a cube number. Perfect cube. Just like perfect squares, these are numbers which can be expressed as a product of three equal numbers. We can talk of 1, because 1 can be expressed as 1 times 1 times 1. Because if you multiply 1 times 1 times 1, we get 1. So 1 is also a what? A perfect cube. Think of the next one. What is the next one? If you got it right, the next one is 8. Because if we multiply 2 by 2 by 2, we get 8. The next one is 27, then 64, etc. These are examples of perfect cubes, numbers which can be expressed as a product of three equal numbers. Wow, I hope we are still together. Now, let us move on to reciprocals. Number 9. Reciprocal. Another word which can be used is inverse of a number, inverse of a certain number. For example, we can say, what is the reciprocal of 10? What is the reciprocal of 15? We can say, what is the inverse of 15? We can say, what is the inverse of 10? So to find the reciprocal of a number, what you can do is, if we are asked to find the reciprocal of 10, reciprocal of 10. First of all, express 10 as a fraction. We can write 10 as a fraction by saying 10 over 1. So the reciprocal of 10, you just invert 10 over 1. This means that the denominator will become the numerator and the numerator will become the denominator. Therefore, the reciprocal of 10 is 1 over 10. Think of any number. Reciprocal of 35. You know that 35 can be expressed as 35 over 1. So if we invert 35 over 1, we get 1 over 35. So the reciprocal of 35 is 1 over 35. However, if we are given a fraction, for example, reciprocal of 5 over 4, there is no need of expressing this as a fraction because it is a fraction already. So what we will do is we just invert it so that the numerator will become the denominator and the denominator will become the numerator. So the reciprocal of 5 over 4 is 4 over 5. That's all about reciprocals. Now, today, we have come to the end of this lesson. We will talk about multiples and factors and prime factors when we do the lesson which involves the lowest common multiples and the highest common factor. Thank you for watching this video. You can like it, you can share it, you can invite your friend to like my Facebook page so that they will benefit from